basic terms, terminology. Strength. It is the ability of material to resist force by developing the stress based on the nature of the force without failure. It is the ability of material to resist force by developing the stress based on the nature of the force without failure. Stiffness. What is stiffness? It is that property. It is that property of material due to which material can resist deformation. It is that property of material due to which a material can resist deformation. Tactility. It is the ultimate tensile strength. It is 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 ultimate tensile strength. Ductility. Ductility. What is ductility? It is the property of the material. It is the property of the material that enable it to be drawn permanently through great change for shape without rupture. This is indicated by percentage elongation and percentage reduction in area from a tension test. Ductility. It is the property of the material that enable it to be drawn permanently through great change of shape without rupture. That is indicated by the percentage elongation and percentage reduction in area from a tension test. What is brittleness? It is the opposite of ductility. It is opposite of ductility. It is the opposite of ductility. It is the opposite of ductility. Brittle material falls suddenly. Brittle material falls suddenly without warning when stressed beyond their strength. They cannot recommend much change in shape without rupture. They cannot accommodate much change in shape without rupture. Hardness. It is the ability of material. It is the ability of material to resist indentation or abrasion or cutting or snatching, etc. It is given as force divided by the surface area of the spherical indentation. It is given as force divided by surface area. Force divided by surface area of the spherical indentation. What is toughness? Toughness. It is the property of material which enables it to absorb energy at high stress without fracture. It is the property of material. It is the property of material which enables it to absorb energy at high stress without fracture. Without fracture. The measuring of toughness is the amount of energy that a unit volume of the material has absorbed after being stressed up to the point of fracture. Toughness is the property of material which enables to absorb energy at high stress without fracture. Without fracture, it can absorb high stress energy. Creep. What is creep? It is the property by which a material continues to deform with time under sustained loading. Creep is the property Creep is a property by which a material continues to deform. Creep is a property. Creep is the property by which the material continue to deform. Material continue to deform. The material continue to deform with time under sustained load. Sustained load deforms. What is resilience? It is the amount of energy stored in the strained body. It is the amount of energy. It is amount of energy stored in strained body. Stored in strained body, also known as strain energy. Resilience. Resilience. It is the amount of energy stored. It is the amount of energy stored in a strained body, also known as strain energy. Also known as strain energy. Proof resilience or modulus of resilience. Proof resilience or modulus of resilience. The maximum amount of strain energy which can be stored in a unit volume without permanent shift is called proof resilience or modulus of resilience. Modulus of resilience. The maximum amount of energy strain energy. Maximum amount of strain energy which can be stored. Maximum amount of strain energy which can be stored in a unit volume. Unit volume stored in unit volume without permanent shift. Without permanent shift. Without permanent shift. Without permanent shift is called proof resilience or modulus of resilience. Proof resilience or modulus of resilience. The strain energy is stored in the body. The strain energy is stored in the body when it is subjected to direct tensile or compressive load. When it is subjected to direct tensile or compressive load, sigma square 2E into G and modulus of resilience square 2E. The strain energy stored in a body. The strain energy stored in the body. The strain energy stored in the body when it is subjected to shear stress. Shear stress tau square 2C into B. 2C into B. The modulus of shear is tau C square upon tau square upon C square. 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 What is elasticity? Generally, almost all the structural material will be capable of recovering original shape and size upon the removal of deformation force, providing they are not excessive. This property is called elasticity. The limit of stress up to which the material can exhibit elasticity is called elastic limit. The limit of stress the limit of stress up to which a material can exhibit elasticity is called elastic limit. Structure material will be capable of recovering original shape and size upon the removal of deforming force, providing they are not excessive. This property is called elasticity. What is plasticity? Plasticity of material is the property of material of which it continues to deform without any considerable increase in stress. Considerable increase in stress. Plasticity of material. Plasticity of material is the property of the material by virtue of which it is continued to deform without any considerable increase in stress. Without any considerable increase in stress. কোনো considerable stress প্লাস্টিসিটি ডিফর্ম হয়ে গেছে উপরে পাঠে প্লাস্টিসিটি primary or linear strain, the deformation of bar per unit length in the direction of force is known as primary or linear strain. For deformation of the bar per unit length in the direction of force per unit length in the direction of force known as primary or strain energy. Poisson's ratio. The ratio of lateral strain to linear strain is called Poisson's ratio. The ratio of lateral strain or linear strain is called Poisson's ratio. The ratio of lateral strain linear strain ratio. The ratio of lateral strain to linear strain is called Poisson. It is denoted by mu or B 1 upon m or B. Usually this varies from about 0.1 to 0.04, always less than 0.5. Limiting value lies between -1 to 0.5. For steel, B equals to 1 upon 3 to 1 upon 4, practically 0.3, and for concrete 0.2. Volumetric strain. What is volumetric strain? Percent of change of volume to original volume. Percent of change of volume, change in volume to original volume, change in volume to original volume, change in volume. Data ratio of change in volume to total volume, original volume is known as volumetric strain. The ratio of change in volume to original volume is called volumetric strain. Ratio of change in volume to the volume of total original volume is called volumetric strain. If the strains in the three principal directions, eta x, eta y, and eta z, the volumetric strain will be the sum of these strains. Delta V upon V equals to what is bulk modulus? Bulk when a body is subjected to three manually perpendicular stress of equal intensity. The ratio of direct stress to the corresponding volumetric strain is known as bulk modulus. It is usually denoted by K. When a cube is subjected to three manually and mutually perpendicular tensile stress of equal intensity, then the volumetric strain is EV equals to delta V upon V equals to 3 delta E into 1 minus 2 upon M. The bulk modulus K. The bulk modulus K. The bulk modulus K. The bulk modulus normal stress on volumetric strain. Normal stress upon volumetric strain. Relation between the bulk modulus and Young's modulus. K equals to M into E upon 3 M minus 1 M minus 2 G equals to M A upon 2 M plus 1. Bulk modulus relationship between concurrent or non-concurrent force. A concurrent force system is a set of two or more forces whose line of action intersect at a point at the same time. Similarly, non-concurrent forces are whose line of action never interact with each other, meaning that they do not have any common passing point. Concurrent. Modulus of rupture, flexure strength, bending strength, fracture strength. These are the same. It is defined as the stress in the material. Stress in the material just before it else in a flexural test. It is defined as stress in a material. Stress in a material just before it else in the flexural test. Flexural test. Flexure test. It before it else in the flexure test. It is defined as stress. It is defined as stress in a material just below it else in a flexure test. It else in the flexure test. Slenderness ratio. It is the ratio of effective length of a column to the radius of gyration. Effective length of a column to the radius of gyration. Effective length of column to the radius of gyration. Radius of gyration. It is the ratio of effective length of the column to the least radius of gyration. The slenderness ratio is L upon R. L is the effective length of column. R equals to radius of gyration. Endurance limit. It is the property of material defined as the stress which a material has probability of not falling under reversal of stress is known as endurance limit. Endurance limit. It is the property of material. It is the property of material defines as the stress which a material has a probability of not falling under reversal of stress is known as endurance test. It is the property of material defined as the stress which a material has probability of not falling under reversal of stress is known as endurance limit. What is defined fatigue? The phenomenon of decreased resistance of material due to reversal of stress is called fatigue. Phenomenon of decreased resistance of material. Material resistance decreases due to reversal of stress reversal है तब ऊपर की कहते हैं fatigue defined as is called fatigue. कोई material में decrease है resistance decrease resistance of material के resistance decrease है तो ये जो reversal of stress correct. Okay, fatigue. Malleability. Malleability is the property of being permanently extended into sheet without fracture when rolled or hammered. Malleability is the property of being permanently extended into sheet without fracture when rolled or hammered. Malleability is the property of being permanently extended. Malleability is the property. Malleability is the property of being permanently extended into sheet without fracture and rolled or hammered. Neutral axis. It is the axis in the cross section of beam or shaft along which there are no longitudinal stress or strain. All fibers on one side of the neutral axis are in state of tension while other on the opposite sides are on compression. It is the neutral axis. It is the axis in which the cross section of the beam or shaft along which there are no longitudinal stress or strain. All fibers on one side of the neutral axis are in the state of tension, while all those on the other opposite sides are in the compression. Working stress, yield stress, breaking stress, and ultimate stress. Yield stress. It is defined as the stress at which material begins to deform plasticity. Yield stress is the stress at which a material begins to deform plasticity. It deforms to plasticity is known as yield stress. Ultimate tensile stress. It is the maximum stress that a material can withstand while being snatched or pulled before falling or breaking. breaking breaking stress. Breaking stress. It is required to a fracture material. Breaking stress. It is required to a fracture material. Normal breaking stress is always lesser than actual breaking stress because the original cross-sectional area of a specimen is always greater than the actual cross-section area under tensile load. Working stress. Working stress. Working stress is determined by the designer of the machine or machine part considering factor of safety. The machine is designed for this stress to reduce the probability of failure to make the machine more reliable. According to the maximum principle stress theory, the failure of mechanical component occurs when maximum principal stress reach the yield stress. Yield stress is not the property of the material. Thus, we consider the factor of safety to avoid while working on the mechanical component. For ductility, working stress, yield stress are one safety factor. For brittle material, working stress is ultimate stress of one factor of safety. Factor of safety. For ductile material, working stress equals to yield stress upon factor of safety. For brittle stress, working stress equals to ultimate stress. Ultimate stress upon deepness on various material. Homogeneous material, the material having similar property throughout its volume. Throughout its volume. Isotropic material, the material having identical property in all directions. Isotropic material having identical property in all material having identical property in all directions. Identical property in all directions, having identical property in all directions. Orthographic material. Orthographic material, the material having different property in different direction. Orthographic. Isotropic material having identical property in all direction. Different property in different direction. Homogeneous material having similar property throughout its volume. आधारमा पुढे के है ना सिमिलर आइडेंटिकल छ mechanism of beam. Various material structure are beam. member which is subjected to bend or flexion. Material member which is subjected to bending or flexion. Member which is bending or flexion. Member which is subjected to bending or flexion is called beam. Tie member which is subjected to only axial load tension. Member which is subjected to only axial tension. Member which is subjected to only axial tension. Strut or column or post. Member which is subjected to only axial compression. Member which is subjected to only axial compression. Vertical compression member, column, inclined compression member, strut. Slenderness ratio of strut is greater than 0. Slenderness ratio of strut is greater than 0. What is truss? A group of ties or struts so designed and connected that these form a structure which act as a large beam is called truss. A group of ties or struts so designed and connected that these form a structure which act as a large beam is called truss. Truss usually consists of members forming angles in one plane. External loads are applied to the joints. Joints are frictionless, hinge or pin. There is no shear force or bending moment in the member. All members are subjected to only direction of force, that is compression and tension. Frame, rigid frame, the structure which has moment resisting joint is called rigid frame. The structure which has moment resisting joint, 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 the resist moment joint.